Hey guys, the main objective of this video is to find the settlement in a layer, but before that we're going to have to find the saturated unit weight of clay, the initial effective stress, the change in effective stress due to a foundation, the final effective stress. We're then going to use this information to find the change in the void ratio, and then we can find the settlement. So let's look at the example we've been given. We've been given a foundation which looks like this. It's like an L shape, and we're interested at the settlement under the point O for this setup of layers. We've got a gravel layer with a water table with at 1 meter below the surface, and below that we've got a clay layer which is 8 meters. So the first thing we need to do is find gamma saturated. So let's do that. We know that gamma sat is equal to G plus E on 1 plus E outside of gamma W. So we have all this information. G is 2.7 plus the initial void ratio, which is 0.8, on top of 1 plus the initial void ratio outside of the saturated weight of water, which is 9.81. If we calculated this, we'd get 19.06 kilonewtons per meter cubed. Okay, so there is the saturated unit weight of clay. So we can then use this information to find the effective stress in the clay layer. We know that when we're doing these types of questions, we need to set the point we're interested in at the midpoint of the layer. So we're interested at a point A, which is 4 meters, because this subdivides the layer perfectly. So whenever we're doing settlement questions, we know we need to split the layer, and the distance we're interested in is the midpoint of the layer. So 4 meters is the midpoint of 8. So we're now going to find the initial conditions. So pretend initially we didn't have this foundation. We want to know the stress, the effective stress at the point A below the surface, just due to the water table and the clay and gravel layer above it. So initially we have a total stress. So we have 1 meter of dry gravel, and then we have 3 meters of saturated gravel, and then 4 meters of saturated clay. So we're going to add all that up. So it's 1 meter of dry clay, so that's 1 times 19, plus 3 meters of saturated clay, which is 21, so 3 by 21, plus 4 meters of saturated clay, which we just found is 19.06, so plus 4 by 1906, we get a value of 158.2 kPa. Now we need to find the pore water pressure. So everything below the water table will be saturated. So we know that the amount of distance we have from our layer to the water table is 3 plus 4 meters. So we have 7 meters of water, so 7 by 9.81. We'd get a value of 78.6 kPa. And then we could find that our effective stress we know is the total stress minus the pore water pressure. So that would be 158.2 minus 68.7. We'd get 89.5 kPa as our effective stress initially. Okay, so this is when we don't have our foundation. But now what happens is we come and put our foundation. Okay, and this foundation is putting a pressure of 1000 kPa on the surface of the gravel. So we're going to have to find what happens at the final, so when we've got this layer, when we've got the foundation there. So what we know is that the final effective stress will equal the initial effective stress plus the change in stress that this foundation is causing. So all we need to find is just change in stress and add that to the initial effective stress. So to do that, we're going to have to be using the techniques we developed in the previous videos to find the change in stress due to a shape like this. So we're going to split this rectangle up into shapes which are going to be nice to work with. So the key criteria we have for a situation like this is that we always have to have our rectangles meeting at the corner O, and that the end shape we end up with has to be this shape we have, this L-shaped foundation. So the way we're going to split this up is like this. We're going to come up like this to make a rectangle. We're going to find the total area. We're going to use this total area of the rectangle. So let's call this AOBC. So we're going to find AOBC. We're then going to subtract AO, let's call this DE, so AODE, keeping in mind that I'm always going to the corner O, so every single rectangle has a corner at O, and because we've gone this one minus this entire one, we need to add on this part here. So we're going to go blue minus red, adding on black. So OD, let's call this FG. Okay, so you've noticed that at the end of the day, all my rectangles I'm using have a corner at O, and plus, when I add them all up together, I get back to the original shape I had. So this entire rectangle, which is in blue, minus the red rectangle, which all have corners at O, adding back on this rectangle gets me back to my foundation shape, and all my rectangles had a corner at O. So we're going to go and work this out now. And another important thing we need to know, so we know that we'll find the breadth and length of all our shapes, and the distance Z is to point A. So Z in our case will equal 4 plus 4 meters. So 8 meters in total is our Z value. From the surface to the point we're interested in, which is the midpoint of the clay layer, which is 4 meters below the gravel, which is another 4 meters from the surface. So it's 4 plus 4, which is 8 meters. So let's start with our first shape. So let's do the big rectangle. So this big rectangle was AOBC. So AOBC, it had dimensions, so 4 plus 2 would be 6, by 6 plus 2 is 8, so 6 by 8. And we know that Z is at 8 meters, so we can find M, which is the length or the breadth divided by Z. So let's do 6 on 8, and N will be 8 on 8, where 8 is the depth in both cases, and this is the breadth or length. It does not matter. This will give us 0.75, and this will give us 1.0. We could then go to our chart over here and find our I value. So we know that it's 1.0 and 0.75, so 1.0, so 1's here, and 0.75 is marked around there. We come across, we get a value of about 0.16 for our I value, so 0.16. We could then find the change in stress, which would be 0.16 by the pressure applied. You know the pressure applied is 1,000, so times this by 1,000, we would get 160 kPa. Okay, so this is, and we know that this is positive, we're adding this shape on. The next shape we're going to be doing is AODE, which we're subtracting. So AODE has dimensions 4 by 8. So AODE has dimensions 4 by 8, and we're subtracting that off. M would equal, say, 4 on 8, which is 0.5. N was equal 8 on 8, which is 1. Okay, we'd then go to our chart and we'd find an I value. I've already done this. We get an I value of about 0.2. You guys can do it in your own time if you like. We would then go to our final shape, which we're adding back on. So that is this shape here, GODF, which has dimensions 4 by 2. So 4 by 2, N would equal 4 on 8, which equals 0.5. N would equal 2 on 8, which is 0.25. We would then use our chart to find I, and we'd get 0.06. So from this I, we can find the change in stress is 0.12 times 1,000, which would be 120 kPa. This change in stress would be 0.06 times 1,000, which we would get as 60 kPa. And now if we were to find the total change in stress, it would be 160 minus 120 plus 60. So if we work this out, so 160 minus 120 plus 60, we would get 100 kPa as our change in stress. So we've now found the change in stress, which means we can find our final effective stress will equal the initial effective stress plus the change in stress, so the stress increase. So the initial effective stress we found before to be 89.5, so this is going to be 89.5 plus the change, which is 100, so we get 189.5 kPa. Okay, I'm going to continue this example in the next video. We're going to now use this information of the initial effective stress and the final effective stress to find the change in void ratio, and then eventually we're going to find the settlement. So check out the next video for the remainder of this example. Hope that helps.